Is Brant not coming?
Welcome, everybody. We are here today to discuss chip number 25. This is going to introduce two new conditions to Chialisp, and we're going to get all the info out that we need to the community so that they can be well informed on what we're attempting to do. So Cameron, did you want to go over why we need this chip first?
Yeah, I think the real impetus for all this was taking a look at some Chialisp vulnerabilities that we've seen in the wild a couple of times. We saw it once with the BetSwap v1, and then we also saw it with Hashgreen. And I think as a result of that, we were just meeting and saying, we got to find a way to prevent this from happening in the future, if at all possible. And we want it to be more than just an update to the docs that says, there's this insecure behavior, don't do that. Because the next time it happens, we don't want it to be just oh, well, you didn't read the docs. We want to do something actively to prevent this from happening because it's not good for anybody. We want to make it so that somebody who didn't read the docs very well still doesn't shoot themselves in the foot with this. So that's where we started with this. I think the things that were on the table were add some new conditions. We were also talking about tooling changes. I think ideally the answer would be both. I think there are some challenges with doing just tooling on its own, which is why we didn't pursue that route. And so, yeah, that was where we started. We just wanted to make it so that this couldn't happen very easily again in the future without somebody doing something intentionally silly. We wanted to make the default easy thing to do, the secure thing to do. That's where our heads were, and that's what we were trying to do. That hopefully can answer some of the questions about like why we chose the conditions we did, because rightly enough, you can do the things, the things that the conditions provide today, you can already do in other ways. We just wanted to make it an easier, safer way to do it by default. So that's kind of the spirit of where we started. Bram, if you wanted to add something, I can hand it off to you.
Yeah. What we're talking about here is behavior within the conditions language, not within Chialisp. So we have two languages going on here. One of them is Chialisp and one of them is the conditions language. And the Chialisp definitely references the conditions language all the time because it produces it. But the conditions language is its own language. We don't have a separate name for it. We just call it the conditions language. It can't do very much. It's very limited. It's very simple and declarative. The conditions language has announcements, which are how coins communicate with each other. The problem that keeps turning up as a security problem in the conditions language is you have these communications between coins where a coin is saying very specifically either I am minting something or I am retiring something. Those are two different types of things that can be announced via conditions. And there are persistent problems with these getting either double counted or not counted, both of which are differing very serious security problems when they happen. So the new conditions are meant to be ones where instead of one-to-many, they're very, very specifically one-to-one, that they must be created and consumed exactly once each. So it's a very clear one-to-one mapping between the two sides of the thing. And this can be done using announcements if you throw in a bunch of things about IDs and use nonces and yada, yada, yada. But that's tricky to get right. And in fact, we have often not gotten them right because you get these edge cases where like you have the exact same announcement could come like twice from coin A and be consumed twice by coin B. And it's really tricky to get this to not be double counted in this particular case. And so with the new conditions, just the default behavior is it's one-to-one exactly the way you think it should be, like by default, really trivially. And that's where we're coming from with them. It's the high level view.
Thanks, Bram. So why don't we pass it back to Cameron? And do you want me to share the actual chip on my screen, Cameron, or do you want to do that?
You can. If we're gonna do that, we can. Yeah, okay. We can walk through the chip. I assume everybody here has read it, but maybe it's worth doing that.
I mean, at least we could just walk through the conditions themselves. Maybe not everything about it. Well, maybe you could just give the base. I mean, I guess we got the overview, but the idea would be that we'd recommend not to use these conditions that are currently being used right now if this were to go through. But okay, I'll scroll down here.
Well, you can still use them, but they should be done when you really are doing a one-to-many announcement. You shouldn't hack a one-to-one announcement with them.
Oh, got it. Okay. So Cameron, do you want to just describe the specification?
Yeah, but if you want to get into the implementation, I can also let Arvid chime in here. But I think, do you want to look at the new conditions? Where are they?
Yeah. Well, the conditions themselves are pretty short, but yeah, here
exactly.
You go.
So the idea was just have two new conditions, one for sending and one receiving, that there would be a restriction to say that, it had to be consumed and it could only be consumed one time. Again, these are things that you could try to do with the existing announcements, but it's very easy to get wrong, which is why we wanted to make it very simple to get right. And we wanted that to become the default behavior that we encourage. And then potentially with tooling, we would de-emphasize the old behavior and make sure that you knew what you were doing if you were going to use it. So the idea was that from a coin, you could send a message. And then from another coin, from the receiver, you would receive the message. And then we would ensure at the consensus level that it was actually received and could only be received in one place. I mean, that's the gist of it.
What happens if two coins are trying to receive the message?
So two coins can receive a message if it's sent twice.
But what if you have two coins that are in the same block that are trying to receive the same message? Who will get it?
That is an invalid block if the count of the sends and receive does not line up.
Okay.
Yeah, which it says right here, spend bundle will fail.
Which, by the way, this can simplify some existing code. I think it's a common pattern right now to do sends and receives in two directions. And right now you can replace that with this just using a single set on each side.
It's worth noting that the send and receive sides, which is just sort of a naming convention that you can just swap around the names and everything is still the same. They're just two different ends of a connection.
This would be doesn't require any forking or anything like that, right?
It's a soft fork.
Right.
That we are assigning meaning to conditions which did not previously have meaning.
So similar to other soft forks we've done in the past with adding new conditions or assigning meaning to conditions. Actually, it occurred to me we didn't really go through the bitmap, and maybe this is a better spot to do it. Bram or possibly Cameron, would you want to explain why we chose the bitmap and why we have 6 possibilities instead of all 8 with 3 bits?
Yeah, well, I can explain if Cameron doesn't.
Go ahead.
So when you send or receive a message, when you're communicating with someone, there's the other side of what you're communicating with, and you have to identify them somehow. And there's some information about them that's important to you. And there are 3 different pieces of information in the payload of an announcement. There are there's their parent ID, there's their puzzle hash, and there's amount. And depending on exactly what you're doing, in terms of the identity of who you're communicating with, one or 2 or all of these may be important to you as far as knowing who you're communicating with. So you specify basically a bit each for these 3 attributes of who you want to be talking to here. And the other side also has to specify how they're identifying themselves. So the 2 sides need to have an exact meeting of the minds about how about what pieces of information are being used to identify the two ends, which makes pairing these things up with counts very easy. The reason there are two funny edge cases is because you have these two pieces of information, the parent ID and the puzzle hash, either of which could like pretty severely restrict what the behavior of this other side is. And so you can really rely on it for security reasons. So 6 of the 8 cases have that. The other 2 cases are where it's amount only or just nothing, just any old announcement that any coin could be making. Now, just for the sake of we're not sure what's going on, we're not proposing banning just amount or nothing from the consensus layer, but just because maybe someone will have use for that someday, but because it skeeves us a bit, we're proposing making it invalid at the mempool validation. So the mempool won't accept it, even though it can be in a block.
Great, thanks. How about we pause for a minute and ask if anybody has any questions so far or comments, especially
I have a brief clarification on the bit mask as well. So
okay.
there are 3 bits identifying the sender and 3 bits identifying the receiver. So it's 6 bits total that are specified in the mask, and both sides, as Brian pointed out, needs to agree on exactly which bits are set in order for the connection to work.
Right, and I think I had that somewhere in here. Oh yeah, 6 bits. Thanks for that clarification. Yeah, did you have a question?
Yeah, so I guess it's about the ease of use. So the mode parameter, it's, from my knowledge, is kind of hard to specify the bits in Chialisp. So would there be a way to make it easier for us to specify that I want the sender coin, for example, to care about the parent and the puzzle, and for the receiver, I want to care about the amount and the puzzle?
Well, it's specified using, when you send or receive, there's a single byte that specifies the whole thing. And the intention is the vast majority of the time when you write your smart coin, you know exactly how both ends should do. And so you just hard code this as a constant for this particular thing of which type you're doing.
Yeah, I imagine it'll work like condition codes. Like no one actually like memorizes the condition codes and writes those in Chialisp. They're just defined as constants, and we use standard library and get those in. So I imagine it'll be the same.
Oh yeah, good point.
Great, thank you.
I guess the biggest difference between the announcement is that this explicitly requires them to be consumed, which is a very useful feature.
Yeah, that's the whole thing. This is very specifically about stopping double spending or not spending.
Yeah, that's definitely very useful.
Right, and useful in preventing or making sure that your spends are secure, right?
Yeah, these issues have been responsible for, well, we have a very small n here, but I would say the majority of critical security problems we've actually seen show up in real Chia's smart coins in the wild. So it seems like a good idea to put something in where it's just brainless. You just use it, and by default, it is secure against such issues.
So were there more questions right now from the community?
But when would this be available?
So the standard way of doing this would be we'd push it through the chip process, and that's, I mean, anywhere from a few more weeks, well, probably a month would be about the minimum actually. And then we'd have a soft fork, and the way we've done soft forks in the past, at least, has been 90 days for activation. We'd have to get into a build before that 90-day window would begin. So let's say minimum 4 months from now would be activated. And maximum could be longer.
Okay, thanks.
However, I believe, Arvid, if I'm not mistaken, is the implementation mostly done?
Yes, the implementation is done. I'm still working on adding tests for all of the cases. There are quite a few cases to test.
Yeah, this is fairly, as far as such things go, this is relatively small code impact here, and not very scary.
I mean, it would be very useful for us because we use this extensively. I mean, we try to use coin announcements, but I think this would be much safer. But yeah.
Okay, Arvid, was it?
I think so. Yeah. Oh, I was going to say, I'm glad you think so, because that was the whole hope here. Yeah.
Yeah, that's the whole point of this is making sure we're on the same page, and hopefully we have broad consensus that this is a good idea. I was going to ask Arvid, was there more that you wanted to add as far as how it's implemented that you think would be important here?
Probably not. I mean, there are like some implementation details, but for the purposes of its behavior, it doesn't really matter.
Okay.
So just one question. And so if you wanted to send multiple messages to specific puzzles, or that multiple coins could fetch it, you would just then create multiple of these conditions, and that's sort of how that works.
Yes. If you want to do like an Oracle announcement, like a price announcement, or a this data layer said this kind of announcement, those can just use old school announcements. That's fine right there. But if you have something where like there's say there's like a singleton that needs to be interacted with the tail of a particular cat, then and there's things that are like issuing coins. Each one of them that does an issuance does its own message to this thing, and it needs to individually receive all of them, not aggregate on either side.
Cool.
Yeah. Okay. So just briefly, the way I think is a intuitive way of thinking of this is all of these messages they have a combination of these 6 properties, right? The sender, parent, sender, puzzle, sender amount, and the same thing for the receiver. This form plus the message as well. This forms sort of a unique identifier for this message, and for each message, there's a counter that counts up for every send and counts down for every receive. And at the end of the day, like when you're done validating the block, it has to be 0. All of them have to be 0, basically.
Okay, and if the identical one is not 0, then it's just the spend model just fails, right?
Mm-hmm. Right.
Yeah. Okay. Brandon?
Sorry, I don't know if this has been mentioned yet, but it would be nice if the default mode were to be coin to coin. That way you don't have to specify it if you're just doing that like default most secure case.
Oh, you mean using all 3?
Yeah. Like if you leave off the mode, I guess right now it's one of the first arguments, so it wouldn't be easy to do that. But if it were to be the last one, then it would be easier to make it optional.
It can't be the last one because you don't know what to parse before it.
Yeah, there's a var args parameter.
I see.
Yeah, we usually make it so that conditions can just have whatever at the end of them for potential future extensions. So it's not obvious how to. Now, in this case, you can kind of go off of length, sort of. Because you usually, I think, like usually the second argument has to be greater than length 1, but I think that might not be the case. Like if you're specifying just amount, I'm not sure. We'd have to go look carefully at what exactly the order of things is and whether you can infer stuff.
Are we going to add these as like variables in condition codes.clib, for example, so you can just import them?
Yeah, as we mentioned earlier, I would expect there to be constants for at least the most common bit masks, and coin to coin would probably be a short name.
Yeah, these can be compiler decisions later on, but if we did want to make coin the default, like I think it'd probably be pretty easy to tell if they didn't put in the bit mask, if they went straight to the coin ID, but we don't have to decide that here.
Yeah, you need to go look carefully at what all the edge, like what exactly gets passed in each of the conditions, and see if there's a way of reliably inferring in each case.
Hey, Yak, you had a question?
Yeah, so normal announcements have announcement IDs that are built from the coin ID or puzzle hash and then the message. Will there be some kind of message IDs resulting from these conditions?
Well, if you're doing the message IDs. Well, sort of. I'm not sure what you mean by message ID, but these things that are getting counted are kind of talking about the message identifier. So the combination of the mask of what the two sides use and the values that mask references, and then the and then the actual message that's getting passed, which is often but doesn't have to be a hash. The combination of all of those is all the important identifying information for the message. They don't really have unique IDs because they can have identical twins. You can have two different messages that are exact same message. They're sent, like, it can be literally both from the same coin and both received by the same coin. And so there's nothing different going on between these things at all. But they're still contributing to the count. They still need to both be created and consumed. So it needs to be 2 and 2. It can't be 1 and 2. Things like that. So there's no way of, you are kind of referencing a message, but they aren't guaranteed to have unique IDs. That they can be, they care about their pertinent information, and they can have like identical twins and triplets and stuff. It's just that the sending and receiving sides need to agree on the exact number of them.
So I interpret the question more like in the traditional create announcement and assert announcement, you assert the hash of the message and the sending coin or the announcing coin, right? Which is something we discussed, that you could have the received message really just assert the hash of everything, all of the identifying information and the message. But the way the chip is written right now, you just repeat the same information as the sender.
Yeah, we considered that. We're still considering that. It depending on how you're doing your compression, it can be a little more parsimonious to just specify the hash on one end. You can't specify the hash on both ends because you somehow need to find the information that's being hashed. But if it's always the same side, if it's like always receivers that can abbreviate using hashes, you can find all your hash lookups by doing all the senders first, and then you can do all your lookups by hash, and then the receivers can just specify a hash of things. That, if you're just verbatim presenting bytes, does make one of the two sides smaller. But if you're actually doing a good job of compressing by referencing values that you used already, having to present the whole hash can actually be bigger than just back referencing saying, hey, reuse those things. So it isn't a super clear win in all cases. But that is something that we may add to it depending on, I don't know, feedback.
Okay, yeah, and anything that gets updated, I'll send out a message to the community to make sure that you see the update. So Art, you have your hand up?
Yeah, from the thing earlier, it seems like the right thing to do is to make a fairly nice macro that people are encouraged to normally use to generate these, so that we can do some processing on it, like check that all the specified arguments are present and such. That would throw at compile time in all cases when you're composing a message that you intend to have as one serve one role, and it's not stated properly in the code.
Yeah, makes sense.
Yeah, so my at least understanding of how this is implemented is these kind of details can be worked out later. That we're doing the soft fork as far as the actual chip itself, and then how the macros are presented or how this is compiled is somewhat optional. But yeah, good point. So what do you guys think? Does anybody else have questions, feedback for us for now?
I think one aspect that was briefly mentioned is that it can make puzzles much easier, because now the way you can get two coins to talk to each other is each of them creates an announcement and receives an announcement for the other. So that's two conditions, and you usually have to hash the same message, or anyway, just having one condition that takes care of the message being received by both parties will make the puzzles a little bit simpler, which is extremely helpful.
Well, thanks for that. All right, I guess if there's nothing else, we can wrap this up. So the next steps are, oh, go ahead.
Just the last thought. Is there any thinking about having a sort of a condition / Chialisp linter, where it analyzes the code and just from the conventions can incur some or create some warnings, or yeah.
We can really only do that at runtime, but certainly providing a mode for running coins in test that, you know, that outputs diagnostics for use of the older conditions, you know, if specified, would be one thing. I encourage everyone to sort of try out the types branch and see what they think of the proposed way of doing type Chialisp. Adding type class resolution, as in traits in Rust and type classes in Haskell, would give it sufficient power to be able to do fairly extensive checking if you want on things like conditions and such. Like we can make framework containers that allow you to plop coins in them, and then verify that they're sending and receiving appropriately paired messages if you want. So that'd be one route, but
yeah, that makes sense. Even just marking something as a solution and something as a current value would probably give a lot of options, or allow you to sort of say, oh, you weren't actually verifying that.
Adding in like compiler checks that you're using announcements properly gets into some really, really crazy cross-language complicated conditions things. It's like, well, it looks like you are making an announcement that kind of looks like it probably meant to verify the like to verify your own coin ID because of the form of this particular thing, and you're not adding an assert my ID when you create the other thing while you're doing it. Those are the kinds of like checks you're looking for without this, so it gets a little weird.
Yeah, I guess it requires a whole story of the full conditions list that were applied, and then based on that. But yeah, it's complicated.
Doing it by construction is definitely doable. We can sort of think about it, and I know Richard just got CLVM running in Lean. So if we like the without declarations, determining those things probably requires the power of a foolproof system. But with declarations and by construction, it's a lot easier.
It's worth noting that doing things right with the announcements is actually hard enough that I think we've never really quite done it right. That like you get these, if you have something where it's like you're worried about double counting or only single counting when you should have been double counting, like someone announcing that they're issuing things, but then it's like done twice from the exact same coin. then that's potentially problematic because it's very hard to differentiate those two. And even if you try and throw in a nonce, they could potentially use the same nonce for both of them because it's coming from the exact same coin. So you get like that particular one is a little hard to hit because often when you have something doing an issuance, it's from a very specific puzzle that always does it exactly once. But still, it gets pretty dodgy trying to like really nail down perfectly all the edge cases without having very involved extra assumptions floating out there in the ether.
Okay. Any other last comments, questions? All right. So the chip right now, I've noticed it still has a couple of to-dos in it that I have to clean up. And Arvid mentioned he has some testing that test cases to be written. So the actual implementation, once that's all set up, then we'll move the chip into review. You can leave a review right now if you want, just do that in the PR in the chips repo. And from there, as long as we have pretty broad community consensus, then we'll put it to last call for a couple of weeks and finalize it, and then get it into an actual build. And then, like I said, it'll be about a 3-month window or 90-day window before it's activated. So thanks for coming out here, everybody. Sounds like you guys like this idea for the most part. And
Thank you, Dan, for hosting.
Thanks.
Thanks.
Okay.
Thank you.
take
Bye-bye.
care.
Thank you, Dan. Have a great day all.
Thanks, guys. See ya.